Hi guys, so today I'm going to show you how to add and subtract square roots when the common square root is not that obvious. Because before you saw examples where you had common square roots, but in this case the common square roots are not that obvious. So when the common square root is not very obvious, the first step is you have to simplify your square roots in order to see if you can get a common square root to combine your like terms, okay? So we're gonna simplify using prime factorization here. So 2 square root of 3 is already in the simplest form because the factors of 3 are 3 and 1, so we can't simplify that any further. So now what we're going to try to do is we're going to simplify the square root of 27 because our goal at the very end is to get a common radical to combine like terms. So the square root of 27 can be split into, so let's look at factors of 27. Factors of 27, we can have 3 and 9, okay? 3 is a prime number, so we leave it alone. And now let's go to the 9. 9 is not a prime number, so we keep factoring. Factors of 9 are 3 and 3. 3 and 3 are prime numbers, so I am done with my prime factorization. Now what I'm going to do is I'm going to write down the square root. Remember, I'm working with the square root of 27. And I'm going to write all the factors, all the prime factors of 27, which are 3, 3, and 3. So let's remember the method about the twins, right? So you rewrite your square root, and then what we have to look is pairs of prime numbers. So right here, I notice I have a pair of 3s. So they are the perfect couple. They're twins. They're going out together. So if they're going out together, we're going to pull it out outside the square root. Or another way to look at it is that you can say one has an evil twin, get rid of the evil twin. So let's keep the 3 outside of the square root. And then this 3 does not have a twin, so we're going to keep that inside the square root, okay? But I'm not done because my goal is to add the square roots. I'm going to bring down 2 square root of 3, and look, I have a common radical now. So now, well, in this case, our common radical is a common square root. My common square root is the square root of 3, so I should have a square root of 3 in my answer, and I'm going to combine the coefficients of each square root of 3. In here we have a coefficient of 3, and here we have a coefficient of 2, and I'm going to combine them. 3 plus 2 is 5, so my answer is 5 square root of 3. Okay? Now let's do a different example, okay? So now let's work with, let's see a fun one. Example 2. So let's say we have negative 2 square root of 6 minus the square root of 24, okay? This doesn't look that friendly because again, the common square root is not that obvious, okay? Square root of 6 and the square root of 24 are not the same, okay? So in here, again, we're going to use prime factorization to simplify the square roots. In here, we can negative 2 square root of 6 is actually in the simplest form because factors of 6 are 2 and 3, which are prime numbers, so we're done with that. But what we're going to have to simplify even further using prime factorization is the square root of 24, okay? So let's think of factors of 24. I can use 6 and 4. If you want to start with 2 and 12, that's fine. At the end, you're going to get the same answer. All right? 6 is not a prime number, so I need to pull out some more factors. Factors of 6 are 2 and 3. 2 and 3 are prime numbers, so I can stop there. And then factors of 4 now, because 4 is not a prime number, are 2 and 2. And look, 2 and 2 are prime numbers, so I am done with my prime factorization, okay? So now what I'm going to do is I'm going to rewrite the square root of 24. So let's bring out the square root. And let's write all the prime factors of 24 inside the square root. I like to write them in order so it can be, you know, it's actually a little easier to see visually the pairs of the prime numbers. So I have 1, 2, 3 factors of 2. And I have 1 factor of 3, okay? So in here, I have a set of prime twins, okay? The 2 has a twin here, okay? So right here I have my perfect pair, the perfect couple, okay? But this 2 does not have a twin, so we leave it alone. This 3 does not have a twin, so we leave it alone. And remember what we said about twins, right? We want to get rid of the evil one. So let's pull out the 2 and keep the factors that do not have a pair inside the square root. Keep in mind that my goal is to get a common radical, okay? I have a radical of 6 here. So in here, you know, I am going to get radical 6 at the end as my common radical, or in this case, my common square root. We can use those terms interchangeably, common radical, common square root, but in this case is special because we're working with square roots. So we can say common square roots. 2 times 3 is 6. So I'm just cleaning this up a little bit. Bring down that 2. Don't forget to bring down that minus sign, okay? And don't forget to bring down that minus 2 square root of 6, okay? And look, now I have a common square root. And my common square root, boom, square root of 6. Now I'm going to combine the like terms. So in order to combine like terms, I want to look at the coefficients of the square root of 6, of each square root of 6. I have coefficients of -2 and -2. So I'm going to combine those and keep my common square root in there. -2 minus 2, that is -4. So my answer is going to be -4 radical 6. Okay? And now we're going to do one more example, okay? In this example, you are going to see a bigger number. So now new sheet of paper. Oops. Okay. We're going to call this example 3. I have 5 square root of 160 minus 2 square root of 10, okay? Here we go. So now, remember, I don't have a very obvious common square root. So we want to simplify any square roots we can using prime factorization. So in here, what I'm going to do is because I actually cannot simplify this further because factors of 10 are 2 and 5. They're both prime numbers, so that's already simplified enough. I'm going to simplify the square root of 160, okay? Keep in mind that 5 is the coefficient of the square root of 160, and it's very important we do not forget about that because at the end it's going to be multiplied next to the square root there. Factors of 160 could be 16 and 10, okay? 16 is not a prime number. So let's pull out some more factors. 4 and 4 are factors of 16. These are not prime numbers. We have to keep going. 2 and 2. 2 times 2 is 4. And look, these are prime numbers. And then 2 times 2 is 4. And those are prime numbers. But we're not done here. We cannot forget about the 10. 2 and 10. Boop. I meant 2 and 5. That should be a 5. Whoopsie. 2 and 5 are factors of 10 because 2 times 5 is 10. And look, 2 and 5 are prime numbers. So there we are done with our prime factorization, okay? And now what I'm going to do is keep in mind that this represents the square root. This 5, let's not forget about that 5 because that's a coefficient of the square root of 160. So we need to bring it down. And let's start putting all our prime factors inside the square root. So I have 1, 2, 3, 4, 5 factors of 2. And then I have a factor of, that's a 5 in there. That's a 2 in there. Okay, and now let's look for pairs of prime numbers. So we have a perfect couple here. Another perfect couple. So we have 2 perfect couples, okay? 2 perfect couples. They have a twin. This 2 has no twin. This 5 has no twin. So we leave it alone. Remember, when we have twins, let's get rid of the evil one. Let's get rid of the evil twin, get rid of the evil twin. So what I'm going to do is I'm going to pull out the good twin outside the square root. And I'm going to pull out the twin, the other twin outside the square root. So I'm going to pull out 1, 2 good twins. And let's not forget about that 5. So you need to multiply that times 5. And then these do not have a match. So you keep them inside the square root. So that's 2 times 5, okay? Now what I have to do is I have to multiply these 3 numbers out because that's going to give me the coefficient. 2 times 2, that gives me 4 times 5 is 20. And let's clean up the inside of the square root, which is 2 times 5 is 10. So I get 20 square root of 10. But remember we're subtracting that with the 2 square root of 10 up here. And don't forget about it. And guess what? We have common square roots. Yay! So let's pull out the common square root, which is the square root of 10. We're combining like terms, so let's combine the coefficients. 20 minus 2. 20 minus 2 is 18. So my answer is 18 square root of 10. Perfect.